today we're going to be looking at how to use the normal CDF function to find areas under the normal curve. First, let's look at what an area under the normal curve looks like. An area to the left, which is the areas that are given in the Z tables, the area to the left of Z equals 1, or 1 standard deviation above the mean, shows an area of 0.841345. This can also be approximated using the empirical rule, since this is 1 standard deviation above the mean. The area to the right will look like this. Notice that this area added to the previous area gives a total area of 1. So the Z tables give the area to the left of a particular value. This is again Z, the area to the right of Z equals 1. Notice that the area to the right of Z equals 1 is 1 minus the area to the left of Z equals 1. So using the tables, we can determine areas to the left, as they are given, or areas to the right by utilizing the fact that the total area under the curve is equal to 1. Now on to the calculator functions. The function normal CDF is found under distributions. Second function vars brings us to distribution, and normal CDF, it will give us the area. Without the wizard installed, we have to enter lower bound, upper bound, mean, and standard deviation. So let's recreate what we just did. A lower bound of, we could use negative 100 standard deviations. That's a good approximation. To an upper bound of 1 with a mean of 0 and a standard deviation of 1. That gives us an area of 0.8413447. Slightly different in the 5 or 6 places behind the decimal place, because we used 100 rather than negative 1 e to the 99, which is the calculator's approximation to negative infinity. The curve goes on forever in both directions, but we're only really interested in the first 4 or 5 or 6 decimal places, and a z-score of negative 100 more than satisfies that requirement. Let's flip the bounds now, but this time let's use the wizard. The lower bound defaults to negative 1 e to the 99, but we're gonna look at the area to the right of Z equals 1, or that is 1 standard deviation above the mean. This is the proportion of values that lie 1 standard deviation above the mean. And I'll use the calculator's approximation for positive infinity here, 1 e to the 99. I could also have used the value of 100, as I did in the previous example. And paste. And notice that these two values sum to 1. This value represents the area to the left, or less than, Z equals 1, and this value represents the area to the right of Z equals 1. Thank you.